Okay, so we'll discuss vertical circle. Okay. So what is a vertical circle? The circle in a vertical plane, right? Circle in a vertical plane. Vertical plane is like when we have a table, it is called horizontal plane. And if you'll see mirror in your room is placed in a vertical plane, right? The mirrors in, so that is a vertical plane. So in vertical plane, we are talking about moving of an object. Okay, so object is moving in a vertical plane. And the object mass is, let's take M, and it is connected with point O. Initially, basically it is at A only. After some time, it will go at B, assuming that it is having sufficient velocity. In fact, that's the point which we are going to discuss. And then it will come at C, and then finally it will go at D, and then it will come back at A. Okay. If you see the journey from A to C and C to A, if it able to reach C properly, right, then it will return back from C to A also. Okay. So the main question what they ask is, what is the minimum velocity to be given to the object at this particular point, right? What should be the velocity at A minimum, so that it can complete a vertical circle? Because if any velocity is given, not necessary it will complete this entire circle. It can leave the circle in between, right? But if you'll cross point C, then it will complete vertical circle. So our criteria is two type. We can divide this entire discussion into. It can leave the circle between A and B point, or it can leave the circle between B and C point. Suppose it is not leaving in these two portions, then definitely complete vertical circle will be there. So till C, our discussion will be there. Once it will reach till C, then it will return back. Okay, so this is one of the things in the exam they are asked. Plus they ask the tensions and other things. Okay, so what we'll do first, we'll get in general relation between velocities at different point with respect to initial velocity. So this is already UA. A is the, let's take starting point for it. A is the starting point for it, and let's take it is at any angle it has covered, and it is reaching at this particular point. Okay, it is reaching at this particular point. This point is point E. This point is point E. So it is reaching from A, B, C, D. It is reaching point E. This angle is theta. Okay, this angle is theta. So it has covered angular displacement of theta, and it is reaching point E. Suppose UA is given. UA is given. And then our job will be to find what will be this velocity at this particular point V. So we have to understand here that given velocity at lowest point, right, at point A, we have to find what will be the point at any unknown point. Like they can ask you when it is covering a distance of angular displacement of 60 degrees, right? Then what will be the velocity? So all these questions will be answered through this discussion. So there are two things here. That is why we are doing after work power energy topic we are doing here, right? So we have to understand this one. Let me draw this one horizontal line. Okay, let's call this as point F. Okay. So if you'll see how much height it has gone up from A to E, what is the height it has gone up? So this height it has gone up, AF. This is the height it has gone up, right? So it has started from A, it has reached at E. A velocity is given UA. We want velocity at E. What we can do, we can use energy conservation here. We can use energy conservation. We can say that there is no loss of energy. Remember that when we say that there is no loss of energy, we are neglecting a resistance or any resistive force applied during the vertical circle. So we are assuming there is only two forces acting on it. There is a gravitational force always, and there's a tension force by the string. Okay, remember this is the vertical circle by a string. Okay, this is a vertical circle by the string. Okay, so vertical circle by the string, there is a tension by the string and gravitational force. No other force is there acting. There is no loss of energy. So we can say that kinetic energy at A plus potential energy at A will be equal to kinetic energy at E plus potential energy at E. Okay, kinetic energy at A plus potential energy at A will be equal to kinetic energy at E plus potential energy at E. Now, kinetic energy at A, how much it will be? That already we know, half mass m UA, okay, square plus potential energy at A. Now, to define the potential energy, we discussed in the previous classes that potential energy is always a relative term. Potential energy is always a relative term. So we can always take this level as zero potential level. Any level for that sake we can take in any calculation, any one level we can take as zero potential level. For the timing, let's take this is zero potential level for this particular problem. Different problem we can take, different discussion we can take different level as zero potential level. Here we'll take this as zero potential level. So plus 0 is equal to kinetic energy at E half m v e square. Okay, or we can just write as v also, because let's discuss it in general. In general, at any theta we are talking, depending upon theta, E can be any point. Suppose theta is 90, then E will be point B. Suppose theta is 180, E will be point C. So depending upon theta, we can always change the point. Similarly, if theta is 0, E is point A. So it all depends on which theta we are talking. So we can say half mv square kinetic energy plus potential energy will be mgh, because h height it is gone up, right? Now for h height calculation, now that is what the second part is, how to calculate the height h. So according to this, let's take radius. This is the radius, of course. These all are radius. This is also radius, which will be nothing but the length of the string itself. So whatever length of a string will take, that becomes the radius. And if that point is the radius, which is L, then we can say OF value using cos theta. What will be cos theta? Cos theta will be OF divided by OE, right? Which will be equal to OF divided by OE. OE is nothing but L itself. So we can say that OF will be L cos theta, which is nothing but this point. Okay. And if you look at carefully here, OF plus FA is equal to OA is equal to radius is equal to length of the string. Okay. OF plus FA is equal to OA is equal to R is equal to L. Now what will be OF? OF will be L cos theta. So this is L cos theta. FA is what? H, what we have taken. And this side, how much it is? L. So from here, what is the value of H? H will come as L 1 minus cos theta. Okay. H is equal to L into 1 minus cos theta. Now, once we know this value, we'll put it here back, and then half m UA square is equal to half MVA square plus MGH. H already we have the value. So we'll put this value H here now, which is nothing but L into 1 minus cos theta. Okay. Now here what we'll do, M will get cancelled. We'll multiply it by 2. So it will be UA square is equal to VA square plus 2GL 1 minus cos theta. Or from here, we'll get VA square value as UA square minus 2GL 1 minus cos theta. Remember, this is in general value valid for each and every theta. VA square will be UA square minus 2GL 1 minus cos theta. This is in general value. Velocity at any point theta will be calculated. In fact, we can just check it very easily by putting theta as 0. If you put theta as 0, cos 0 will be how much? Cos 0 will be 1. So from here, what will be VA square? VA square will be equal to UA square minus 2GL 1 minus 1. 1 minus 1 will be 0. So how much it will be? UA square. It means VA is equal to U. And that is exactly V. Okay. Because if put theta 0, then that will give us the value at this point. So this is VA square. Okay. So this value is velocity at any point. Now the second thing which generally the question they asked is related with tension. What will be the tension at any angle theta? So that's what our next point of discussion will be. This is velocity. Let's calculate for tension using the same diagram. We can utilize it. Okay. And let me just draw a free body diagram, okay, separately here. Try to understand it. I'll try to make it in single page itself. So this is a point E. Tension is this side. Tension will be a pulling force. So tension is this side. Okay. This side is tension. This is point E. This is O. This angle is theta. Right. This will be theta. So this direction will be T cos theta. And this direction will be T sin theta. Okay. T cos theta and T sin theta. This will be, if we'll break the tension into two parts, vertical and horizontal. But what we are going to do, instead of breaking the tension into two parts, now we will do in a different way. We'll break the mg into two parts. Because in any circular motion, remember, the two important direction is tangential and radial. So vertical and horizontal is general the direction taken, but in any circular motion discussion, remember that these are the direction we should work it out. So mg is acting in vertically downward direction. Mg component, if this angle will be theta, so the mg component in this side will be mg cos theta, and in this side mg component will be mg sin theta. Okay. Now it's very simple. Once we have this free body diagram, remember the mg has been taken into components. So if we want, we can forget about this mg. We can just think that mg is having mg cos theta and mg sin theta in this direction. Now tension is towards the center. Mg cos theta is away from the center. We know one golden point about circular motion, thumb rule. I discussed that any circular motion, the most important thing is centripetal acceleration towards the center. So in this case, the centripetal centripetal force, which is nothing but mass times acceleration. Acceleration is mv square by r. R is radius. Radius is here L. So mv square by L. Centripetal force. What will a centripetal force? T minus mg cos theta. So T minus mg cos theta, because T is towards the center. Mg cos theta is away from the center. So T minus mg cos theta, T minus mg cos theta will be giving us necessary centripetal acceleration, which is mv square by L. From here, what will the value of T? So T will be equal to mg cos theta plus mv square by L. Okay. Or mg cos theta. Already v square at that same point. Point E already we calculated. How much is it? U square minus 2gl into 1 minus cos theta. Okay. So already we have knowing this one, that in terms of this one, let me just change it to capital L. From here, if we'll cancel it out and open the bracket, mg cos theta plus m ua square by L minus L will get cancelled, 2 mg into 1 minus cos theta. From here, mg common out, cos theta minus 2 into 1 minus cos theta plus m u square by L, or it will be equal to mg cos theta minus 3 minus 2 minus 1, so it will be 2 plus 1, so it will become as 3 cos theta minus 2, 3 cos theta minus 2 plus m v square by L or u square by L. So this will be tension at any point in a vertical circle. Remember, this is a vertical circle. By the string we are talking. We are not talking about by the rod. That is an entirely different discussion. Here, tension is a pulling force. So tension is towards the center always, towards the O. It cannot change its direction. The pulling force on this object, which is performing vertical circle, tension will be always towards the center. It cannot change its direction. Okay. So that point we have to understand clearly. So any doubt in this? Any difficulty now? 1 second, just see it fully. So this is a full discussion, but this is not the end of the discussion. There is a second part of it in which we are going to discuss minimum speed possible. Okay. So this is in general formula. If velocity at A is given, how to calculate velocity at any point and how to calculate tension at any point. This is how we can understand this. Okay.